So hi, my name is Neil, and today I'll give a small presentation about how machine learning could be used by designers. So actually, try to make it a little bit more approachable. Hopefully, I'll succeed. Okay, so recently I think AI and machine learning has been given a lot of attention in the press, etc. But I'll tell you a small secret. I mean, it sounds all fancy, but it's basically usually pattern recognition. And once we find out what the pattern is, we can use it for prediction. So for example, here we have a bunch of dots with x and y values. So for example, if I had another dot with x value 80, you can kind of guess it will be somewhere around here. So that's more or less what the machine learning does. Then there is also this, guys. It's called outliers. So sometimes it could be due to an error. Somebody didn't write down the numbers properly with an extra zero. Or sometimes it's actually accurate. Something really extraordinary has happened. So typically in machine learning, we just get rid of that because this makes our models not so good. We discard it. But this could be actually the beginning of a next pattern. This actually could be very important. Especially I think for designers, you guys, we as machine learning, we usually look within the box. Anything outside of the box is bad for us. We try to get rid of it as much as we can. But I think for design, this actually could be much more useful. So that's one of the points I wanted to get across. So now we'll do a small pattern recognition exercise. So does anybody see any patterns in this picture? And please say so.
The red bikes.
Red bikes, yes, one of the patterns. The colors.
Orientation of the bike.
Yeah, orientation, heading.
Like triangles.
Saddles.
They're all very rusty robots.
Yeah, all. I'm a robot. Also, like some people have bags. I think that's usually to keep them safe from rain, or it's not really working so well.
All the tubes.
So actually, in this simple picture, you can actually find hundreds of different patterns. So an important question is which patterns are important? Because in machine learning, we can have a lot of data and can find so many patterns. And only really humans can decide which pattern is important because we can actually look at it and say, oh, this looks interesting, or this is. Of course, all the bikes have two wheels. I already knew that. This is nothing new. Also, if I'm the person that is looking for my own bike, I'm doing a very specific pattern recognition. I'm just looking for my bike. So the kind of rules I might learn would be very different from, let's say, from the parking meter enforcer who are actually looking for the bikes that don't have the proper stickers. So one of the points is there are many patterns, but we should be able to judge which ones are useful or not. And I think humans are actually still the ones which are better at doing that. So trying to kind of step down a little bit to a more conceptual level, all the pattern is just some kind of groupings. So here, for example, we can group these points based on position. So how many groups do you think here?
6.
3.
2. Depends.
So you're all right or wrong. It depends. So we can group it in many different ways. And then I think only the trained professional can actually look at the data and say, okay, this grouping makes sense, or this is why it's grouped this way, why it's grouped that way. So there needs to be some guidance, usually in machine learning. It's not all completely automatic. So another one of the kind of baselines of machine learning is we can always use more data. Actually, a lot of the improvements in, let's say, text processing has been actually, to the big part, is just we have more data. Algorithms, actually, many of them are still from the 60s or 70s. But once we have thousands and millions of texts, we can do much better. So here, as we add more points, we can actually start to see the pattern much more clearly. So this is one of the things that in design, if you can get as many points as possible, this is always good. Another part is dimensions. So, didn't think I don't have my laser pointer, so if we just have a single dimension, it's really hard to see what the pattern there is. Okay, there's pinkish and less pinkish. So we have no idea what it is. But as we get more and more data, we can actually see what the actually underlying pattern is. So ideally, you might want to get as many different data points or different dimensions about your products or things you're trying to model. Although one of the big problems with that is as you increase the dimensions, let's say this is user interviews. If you are only interviewing user about the satisfaction, they have one question, 5 answers. If you add another one, you suddenly have exponentially more space to cover. So instead of needing, let's say, 5 points, now you need 25. If you add a third dimension, this increases. So it's kind of double-edged sword. If you have more patterns, it's nice, but then actually you need to do a lot of more work to try to get the data out, unless the data is already there. Sorry, did you have a question?
Yeah, on this note, so as you mentioned, the more dimensions you have, it's called the curse of dimensionality, right? So is that really a good suggestion to have, that you have more dimensions? Because the density of patterns would be it would be like trying to find a needle in a haystack.
So I think that's one of my points is, you don't know, because first of all, if you have 1,000 dimensions, you might need only 100 of them or 20. So there are some ways to address it. There is one thing called feature selection. You have 1,000 dimensions and you can actually try to select which of the dimensions actually carry information. So, but I think it's just something you should be aware of, because many people say, okay, we have more data, but it comes at a cost. But at the same time, sometimes actually more data is good because you can actually see the pattern much better. So you have to really, I think that's one of the common misconceptions currently is people always hyped up about big data. We want to have as much as possible. Yeah, it's nice to collect it, but you shouldn't be using all of it. But I guess you can store it if you can. So yes, thank you for the question. And I think also more data, the biggest problem is once they get beyond 3 dimensions, people are not really very good at it. So we really have to rely on machines to try to find the patterns and the way to guide it. Another kind of complementary point is it's always nice to get data also from different sources. And it might be something that's very different from what you actually thought initially. Maybe not even within your previous realm, like weather patterns or whatever, but it might be handy. So if you can combine many data sources, you might actually be more efficient at predicting the patterns. So here's a small exercise, some flowers. How many groups are here?
How many groups?
How would you group these flowers? Or is it the same flower, 3 different ones? What's the
Size of the petals.
So you are prohibited from speaking.
Oh.
I guess you've seen that exercise before, but
No, I don't.
oh no, okay, then you are a very good gardener. So in a way, yeah, it is. So this is 3 different subspecies of the same flower. So that's another one that actually, if it's the same flower, but there's 3 different subspecies. So depending to whom you talk, the right answer could be 1 group because it's the same species. It also could be 3 groups because it's 3 subspecies. And as Elisa cleverly mentioned out, many people will try to say, oh, one of them is slightly lighter, another one is slightly darker. But actually the easiest way to distinguish them is basically the petal lengths and petal widths. Because then if you plot these flowers, they kind of fall into easily distinguishable groups. Which actually this is an ideal situation because we have everything in one bowl and we could not separate it out. So if by adding more dimensions you can separate things out, that means you're doing well. So a little bit of nomenclature. So usually we have, let's say, 150 different flowers. We call it instances. Different measurements, we call it attributes or features. One of the features could be your output value, something you're trying to predict. So here, this is the name of the subspecies. And so this is, you don't need to know much, just to make it look complicated. Okay, so a small exercise now. Try to think of a simple algorithm that you would create, computer doable algorithm that would distinguish these handwritten threes from one another. So I'll give you 10 seconds. Or please actually speak if you're new.
Image recognition?
Yeah, image recognition, anything. How would you can say 3 is defined by 3 slashes and a
Percentage
circle, or
black to white.
yeah, that's one. So there's the color differences. Any other suggestions?
Who said something?
If you draw a vertical line,
Mhm.
then you can count how many times the line is crossed by white. Or
Perfect.
something
Actually,
like that.
this is the best, most efficient algorithm. So, if you did it 30 years ago, you would get a nice award. But this is a very small algorithm. Basically, you have 6 rules, and then it basically counts how many overlapping rows there are. But you can come up with many different other rules. So sometimes it's a matter of efficiency and also how well it works. So next question, machine learning is just a hammer, so you can do many things with it. So how would you think of applying AI or machine learning to photos of people?
Tagging friends.
Sorry?
Tagging friends.
Tagging friends? Would she be your friend?
Distribution of pixels.
Yep. So one thing we can actually enhance the image, or sometimes actually de-enhance it, depends on what we want.
Detect facial expressions.
Oh, I think you might have seen my slides before, but so precisely. So I think Movie Lie to Me made all of us professionals at detecting expressions. So actually, by looking at different features, as position of your brows, your lips, your cheeks, you can actually predict what the person feels. I probably need such app for my wife because I'm still bad at it. She always says that I'm predicting the wrong emotion. So another part which is important. So here we have a single person and we can detect the emotions. But the good algorithm should work on other people as well because it just makes sense. So one of the easiest ways to do that is just basically through simple geometry. You pick some points. Actually, the points positions are very important because they give you a lot. Like for example, this is a good point for your mouse or for your eyeball. But anyways, basically you can detect emotion with just some basic geometrical properties. So, anybody have ideas what other data we can use for detecting emotions?
Shadow. Shadow.
Blood pressure.
Blood pressure. Oh, that's good.
Heart rate, sweat.
Sweat. That's good. Anything else?
Pitch of your voice.
Oh, pitch. Oh, great. So there are many data.
Pupils.
Sorry.
Pupils.
Oh, yeah.
Yeah. Sorry.
So actually, you can kind of see that I think a lot of job of machine learning is usually you're given very hard task, and in a way you're trying to cheat by trying to find some easy data that will tell you, or cheat, but make your job easier because doing this stuff is actually kind of complicated. You need to have some computational geometry background.
Yeah, maybe we'll be getting to this in your presentation, but it's essentially you're looking for correlation, right? If you want to say a person is engaged, you want to look for correlation if happy means this, but sometimes it can be that A is caused by B or B is caused by A, or A and B are caused by C, an unknown variable.
Oh, of course. So this could be, people do fake smiles, or people might be smiling because they saw somebody in the audience, and they actually didn't really care about my lecture though. So, there are many different noise. Sometimes we call it noise if we want to ignore it, or if we don't, if you actually accomplish it, it's actually some external influences. So, one other one is body language. I think everybody knows it. Because humans are not only head, right? We have bodies as well, so we can actually look at your body language. And this could actually give us a very good hint about what kind of emotions you're feeling. Another one is actually just digging into your social media. If you're posting a lot of angry messages on Twitter, probably your smile is not a friendly smile, or the other way around.
Is the correlation?
So you really can dig. You can look at your friends and your friends. Nice fellas, or they're angry, or you can imagine.
Too much tension.
So another one that you can use is actually try to see how the algorithm works with different species. You know, when monkey smiles at you, is that good or bad? So you can actually see if it actually works for taking it a step further.
It's quite interesting. If you hold your camera up, it's quite funny because it won't spot the faces of the apes.
Recognize the
Yeah.
monkeys.
Yeah.
Oh, so,
Which
It
is
doesn't recognize any monkeys, does it?
so actually you can see so that somebody at Apple didn't
Starts complaining.
properly took too many pictures of monkeys.
Monkey rights.
Probably it
Monkey
recognizes
discriminated.
Monkeys will start complaining.
Yeah, primates are people too, almost. So another ones you can use it for is face recognition. You know, every time you go through border security, that's what they do. When they tell you to smile on the camera, it's not for your Instagram update. No, I think everybody knows this. So there is some interesting research as well as how can you fool face recognition. So you can actually see some of these patterns will actually throw off algorithms. Many of them are very extreme, so unless you're a rugby player, I don't think you can have such a makeup. But I don't know, like maybe this girl went slightly heavy on the makeup, but it can really throw off your face recognition algorithms. But actually you don't. So for a lot of research is how to make something better, but there is another branch is how to make existing algorithms not work. So it's kind of race, you know, cat and mouse. So there's some other kind of applications as well that you can try to detect objects in the picture. So for example, here we do some simple edge detection, then we can do some boundaries, and then we can actually separate it in the end into two different objects. For humans, it's actually very simple because you know we are kind of wired for that. But for machines, it's hard. And also imagine if I just showed you 10 pages of 0 and 1s, probably for you it would be hard as well to figure out what's one object, what's another one. So also sometimes, often when we make image recognition algorithms, we will try to capture some essential properties. And this is slightly odd style, but I think in a way it exemplifies what we're trying to do. You try to pick up some common features which distinguish an object clearly. So once it works, we can actually do more advanced algorithms. We can try to spot the objects in different pictures, try to see the relations. So for example here, you know, we can spot a person and bike, and by doing some analysis we know that person is usually on a bike, or with a bike, or by a bike, like Chris says, right? So we can see the different relations between that. So by now you're probably wondering, what does this have to do with design? And we did a project together with Chris and Elisa, which kind of did a slightly cookie take of that. But I think so you might recognize some of the people here. It will be a brief case study. So what we try to do is we try to innovate with the fork. And usually when we talk about innovation, people will take some dimension. So one dimension in capitalistic system is usually cost. How cheap can you make a fork? So you know you can use different materials, you can make it less breakable, etc. You can also go for aesthetics. How beautiful can you make a fork? So many different dimensions you can try to improve. But as you probably know, that all the forks look the same. It's actually really hard to innovate in the fork space. So we kind of asked, so if we really want to innovate, what can we do differently? And some of the ideas that Chris and Elisa had was, what if we change the way we use fork? So typically we use fork for eating. What if you use fork for painting? So this gives it a really different function. And then now we think about fork instead of as an eating tool, more as a painting tool. What can we do? So here, for example, some examples. The person said, how can I make fork a better painting or writing tool? And here are some outcomes. Actually, this one looks pretty good. I'm a big fan of big pens, and as a student or researcher, you have always one, so you're always hungry. So this will come in very handy. Oh yes, make it flavorful one. So an idea was that we can look at an object like a fork, and in our project we mostly use forks, but it could be any other object. So we're not fork fetish people. And we can discover different usages. And then as you look at different usages, you might be inspired, or inspired sounds too fancy, but you might come up with other product ideas. Okay, so please think of some ways you could use fork. Please speak up.
Do the hair.
Oh, nice.
Weapon.
Yeah.
Screwdriver.
Oh, yeah. Scratching cars. American territory.
Tiny herb garden.
Yeah.
Oh, nice. So
Sand garden.
we can come up with some, but if I asked you to come up with 100 usages, do you think you would be able to do that?
Given enough time.
Okay. We'll bring you on our next project as a consultant. So hopefully the answer was not. So that's where machine learning comes handy, but well, it's still arguable. But so what we did is basically we crawled internet for many images of forks, and we have, I think, 10,000 pictures of forks. So that's great. And what we use the AI for is actually to separate which forks are used in a typical manner and which ones are not. So we went through the database, and I think only 5% of the forks are being misused, or even less. Probably in reality it's much less, but people will always post funky pictures, so you actually get an over-representation there. Then you can actually, so we looked at these pictures for a long time and thought how to group them. So here are some groupings we came up with. So one is basically your deviation. So basically you have exactly the same physical object, but just how you use it is different. So here you use it to paint, to do some weeding out, to make some beautiful bows. Another one that came up is hybridization. So we have the basic fork, and you actually try to attach something else to it. And most of this looks really fun, but completely useless, I think. No, this one is my favorite. You need to get an exercise. It's quite nice. This is totally like SkyMall. Fortunately, out of business now, but I don't know. I think this one could be actually kind of doable in one day. So there is also partial hybridization. So with a lot of spaghetti, you can pre-wire your fork and it will roll up spaghetti for you. This one is actually quite interesting. It became kind of popular in its niche. Is you have a fork and you have a small hole for a container, and this is aromas. So actually your brain is really tricky, because when you eat something but you smell something else, you will have very, very different experiences. So McDonald's might want to invest in this technology. But I mean, you can kind of see that some of it could be interesting. Chris was trying to use this one.
Oh yeah, that's right.
So also you can actually do repurposing. You have fork that is used as a fork, but you actually try to make it into completely something else that has a very different purpose, like hanger or jewelry or antenna. And of course you can also, as popular, is just put a bunch of sensors on it. I think maybe you've all heard about this app. It's kind of nice that you put sensors and it tells you how fast you eat. So it can kind of give you some feedback. Another one is, fork is a way it is for a reason. I think probably evolved over many hundreds of years. So it has some very nice support properties, because when you eat your food, you don't want the food slightly to drop. So actually, if you see, it's actually very good for healing your joints. So actually, this is kind of new use of a very common object. So I think by kind of thinking about an object in a different manner, you can hopefully do a little bit of radiation. So for example, here is one of the examples. If we think about a teapot as a handbag, what kind of things can we make? Another one, we can actually do a little bit of automation. If you think about a koala in a cup. What is the proper mixture? Do I want my cup to be exactly like koala, slightly like koala? And I think some of this actually could be done by computer because you can kind of morph things here and there. And I think now also with the web you can make a fake image, post it on a website, I don't know, eBay, and see how many people click buy. And in a way you can actually almost completely automate some parts. And many people want to buy this one, that's what you make. So one of the things is we showed you, a simple fork. It actually has very many different usages, but it's very simple. But if you think about all these other devices, how they could be used in different ways, this could really, hopefully, make some of them a little bit more innovative or find different usages of the objects. So I'll go to the next part. Before I do that, does anybody have any questions, comments, criticism?
So the role of the machine learning in the fork example was just to shift out the normal forks, the regular forks from the spray forks, right?
Yep, yeah.
But there was no
So, but basically, I think it's because you have so many images, and people could probably do it, but people are very good at images, but for example, if it was some other data, then machine learning would be more useful, I would say.
What features did you use in sorting of the images?
It's a good question. So actually, we, as I implied, not cheated, but what we use is actually textual data, because image always appears on the website, and actually if the website says something about food or eat, that's typical usage. If you don't see food or eat appear, then it's atypical. But it's, I think this is kind of, most companies kind of do that, like Google Images. You think it's very smart, but it's usually just looks at the textual data, because it's much more descriptive. And another thing is image recognition is actually very expensive, because to do all this layering, we didn't have enough budget. But it's a good way to invest more.
Yeah, I just want to comment. It's interesting that you, so with the machine or by looking at patterns, you try to look at qualities, and qualities can become new values, right? Which links up to other things we'll be doing in the workshops.
Yeah, and I think also another one that, for example, reuse. Maybe you have some objects. You don't need 10 objects that have stick. You have a broom, then you have something else. So you have basically 10 stickable objects. Maybe you actually can just use one of them and recombine it in different ways. Or if somebody throws away something, can you actually reuse it as something else and make it part of something else? So I think there are many different kind of angles one can take. I think in a way it's actually supposed to make you think creatively. So I think by showing people different images, hopefully people will think a little bit more. Okay, so what we did in our previous part, we looked at how things were used. So you have a fork and it's used for eating. But you can also do reverse. You can actually say, okay, if I want to eat, what should I use? Although eating, we kind of had enough of forks by that time, so we decided to switch to something else. So, trivia question, which innovation resulted in 300% rise in trade in 5 years after adaptation? This is huge, if you think about it. It's probably one of the biggest inventions of the last century.
Shipping containers.
Yeah. So this really, it's a very simple idea, but storage is very important, right? So this actually shows you that if you can find out a really new way of doing something, this could have a really, really huge impact, even though it might seem trivial. So then we said, okay, so can we find some spooky ways of storing things? And actually I'm based in Japan, and it's very expensive. It's probably not as expensive as London, but it's still, you pay dearly for each square meter of your apartment. So Japanese became very good at optimizing your storage. So for example, here, stairs, I use the storage. But here, people kind of flip it, and they actually use storage as stairs. So you can kind of see how you can already start, being much more open-minded about functions, etc. So here are some other ways. Some of them are practical, some of them are not. but in a way how you can actually think about storage. This is not quite storage, but it is, you store yourself. You read books, so why don't you do it in the same place? Ties, etc. This one is kind of interesting because it's quite reconfigurable. Because now we have our shelves which are straight. I always have books which are too big or too small, or some other object that I want to put in, and doesn't quite fit into this rectangular pattern. So here you can actually move things around much more flexibly. It turns out actually that the most innovation in storage is actually watermelons. They are really ahead of this. So instead of trying to optimize storage for the watermelons, why don't you actually optimize watermelons for storage? If you make watermelons square, you can pack a lot more of them.
It's really flipping
Yeah,
the relationship between object and practice.
Yeah, so it shows you, you can attack the problem from any angle you want. Also, very fun way to store alcohol is inside a watermelon. You make a hole, it will seep through, and everybody will enjoy it. Also, juice. I mean, watermelon, its biological design is to store things. So it's actually a very good juice container. So if you just properly hook it up, it's completely reusable, so it's a nice thing. It's probably perishable too, so you shouldn't be using it for too long. So, good pictures, but is this practical? This is maybe not the best example, but now we don't think about phones as phones. Actually, even when you look at advertisement, they advertise everything but the phone function. They do not even mention how clear the voices are, because this is not something we care about. Maybe it's already good enough, so they don't think about it. So if you can think of different usages for same objects or different ways of doing things, I think it could lead to some innovations here and there. And I think I was too quick. So this is all I have. So no, I left some time for discussion. So, and also Chris and Elisa. So I was mostly just doing machine learning part, distinguishing the forks. So I think Chris and Elisa are the brains behind this operation. So if you have any questions, you can torture them.
Not about machine learning.
Yep.
So, from a process perspective, what kind of frameworks are you using? Do you use some APIs? What kind of data sources are you most confident about?
Okay. So luckily, there's a lot of open data. So APIs is one of them. So you can go to some websites as Mashable or whatever. So you can actually find APIs that provides a lot of data for you. A lot of open data sets. Also, the good thing for not as technical users is that tools have been getting much better. And there are many tools which are easy to use. For example, Tableau, I don't know if you used it. It doesn't quite do machine learning, but it will do the data visualization, which is kind of one of the steps toward it. It's becoming very good. There's another one. So, actually, as a machine learning person, I'm actually quite worried about my own job because now the tools are actually quite good. So often they actually can do better than me. So one of the reasons to start thinking more conceptually is I can actually design algorithms that will get better results than me doing optimization by myself, which is kind of interesting thing. So I make algorithm, but it actually beats me. Because basically just a very exhaustive search of different opportunities, while I use some intuition how things could be tweaked. So actually, that's one of my realizations for my research. I used to be very good at certain models, and that's what I did, kind of was always tweaking it. But then actually you find out that actually if you run it on thousands of machines, it will actually come up with better solution than yours. So then you should actually be doing something else, because if you just continue doing that, you're going to be out of job. So you should think more conceptually, or which features you should be using. I think data sources is kind of like a puzzle. What other data can you use? Often, sometimes it would be something very unrelated. For example, we talked with my colleagues, if you have to distinguish a picture of the breakfast, what would be a good feature to do that?
Coffee.
Coffee is good. It's
Bowls, or plates or bowls.
The time that the picture of steak.
Yes.
So, actually, with that single feature, I can get 90% accuracy of what's not breakfast. If it's after 12, it's not breakfast. Or in rare cases, 10% of people. So it's a very, very easy one. One line of code. So it's a really fun. Like I really like my job because it's basically doing puzzles, and you get paid for it. So
something I think we as a team we worked at is how do you know how big a data set is or needs to be to make machine learning pattern recognition worthwhile? Because you said 10,000 forks, that was viable to then pursue something, but 1,000 forks,
Oh yeah, so what you do typically, you just do the plotting. So you can train your algorithms on 100, see what kind of accuracy you get, then do it on 500. So usually most algorithms will kind of go like this and then it will flatten out. So once it's flattened out, of course the thing is, sometimes it flattens out and then later on it suddenly picks up again, but it's kind of a good stopping criteria. Usually when something was kind of doing well and then suddenly started flattening out, then you can say, well, probably I have enough data.
So you're saying that it's hard to tell how many data points you need. You need to basically collect as many as you can until that point in which
So
nothing interesting comes out anymore.
Conceptually, you should actually get as many as you can, because it never hurts. But so some points we can actually get for free, like images search. The cost of getting an image is almost zero. But actually, what's expensive is labeling them. So I spend many hours staring at forks and say, okay, this is a fork, this is not. So that costs human effort. So I would not be able to do a million pictures. So if there's a human cost involved, then yeah, you have a natural limitation. Another one is that sometimes when your algorithm flattens out, it could be just because you're using bad algorithm. Because if you're using some other algorithm, or 1 year from now there'll be a new toolkit which might actually do much better. So it's all kind of temporary. But I guess flattening out usually works as a stop.
But in general, you need bigger data sets. Is that fair to say, or big is relative, of
The
course?
thing is, sometimes if you have too many dimensions, for example, so many points, many samples is good. Because if you are sampling the same dimensions, you're getting more confident. Like probabilistically, you're just getting more confidence in your answers. But once you get more dimensions, that could be a double-edged sword, because I can add you as one of the dimensions, BBC's programming. But if I'm doing my research in Japan, it has completely nothing to do with predictions, but it will actually could lead my model astray because it just happened that there's some coincidence. And it just basically also increases your space exponentially. So you kind of want as much as you want, but then later on you kind of want to do a little bit of nitpicking. What actually do you use? But I think also you can actually examine, like, okay, does this make sense? You can kind of go bottom up. Find some patterns, you look at it, and actually, when Barney comes online in UK, everybody does something that affects Japan. So maybe you should use the BBC scheduling as one of your indicators.
Is it common practice in machine learning to first make your algorithm and test it on a small data set, and then optimize it, and then use it on a larger data set afterwards? Or you just always use as big data set as you can get?
So good point. So often we actually do subsampling. So actually, it depends how big your algorithm, how big your data, because some data is just too huge, and it will take you too long to do. And if you have a smaller data, you can try many more different model variations. So typically, you would do some subsampling and see if it works or not. It's kind of back and forth. Sometimes you will optimize it on a smaller set and try it on a bigger one, see if it does better. You kind of go back.
So
more kind of back and forth.
Is this can you kind of compare it as working iteratively as a designer too?
Probably, because also I think like once you actually look at the data, you might actually find out many different things. I think as a user interview somebody, when you look at things, some of the patterns, you say, oh, I maybe should get more temperature data because one sensor seems to be really doing very well, so maybe I should try to get just the one temperature sensor in the room, I should maybe get 3. Or another one is actually sometimes what we do is when you have many dimensions, instead of trying to have one big model that will try to learn everything, try to have many small models which will learn things. For example, in the image recognition, you might have just eyebrow model that will just actually recognize where your eyebrow is. And with ladies, it's hard because now they start to draw eyebrows. So But anyway, so another one is kind of to decompose it into different models. So then you can do that as well.
One maybe follow-up. And how much would you say effort is put into picking the right data sources, or actually writing or coming up with the algorithm?
So it really depends on the task. So for example, let's say Google, they spend, if you can improve the ad prediction algorithm by 0.1%, this is hundreds of millions of dollars to them. So they can spend a lot of time for this 0.1 prediction accuracy. For us, some other tasks, usually 80% is fine. I don't care if it's 85. Like with forks, okay, I get some wrong ones, but no big deal. I don't need to spend, half a year trying to get another percent. But one of the kind of hypotheses, because AI is getting pretty good, and so some people say, well, people will be displaced. But one of the things is that people are actually usually very good at selecting the features. Like, what does constitute a face? Machine usually just sees pixels, or you can actually see some already pre-configured dimensions. But humans are much better at trying to abstract things out. Like, what is a breakfast? You can abstract it as procedure, you can abstract it as physical things. So this is something that people are pretty good at. So it's called feature engineering. So maybe a good example of that is, maybe you heard there was a kind of movie rating prediction competition. It's called Netflix. So people who gets the best accuracy gets $1 million. And it's funny, everybody gets like around 87%. So in the end, the person who got 87.11 or something like that. So this one small jump was worth $1 million, for example. But there was some very interesting work. One work that was very nice was actually by psychologists. And his finding was very simple. I mean, once you read it, it's like, yeah, of course, this is. So what he came up with, actually very nice analysis, that we have kind of movie inertia. If you watch the bad movie, it's like maybe food. If you ate some bad food, you have bad taste in your mouth, and then if you eat something mediocre, it already tastes much better. So actually, you might actually rate it much higher. On the other hand, if I actually ate really, really fancy food, and then I had that food again, I would actually rate it lower, even though the object itself hasn't changed. So what he found that actually people have natural fluctuations in your own ratings. And then one of his findings that was that they could not do better than, I think, 93%, because naturally we have 7% variation. So we cannot even predict ourselves. Like sometimes if I think, what did I rate this movie? Like, oh, it would have been 4, maybe 3. So this is kind of 1-star deviation even. I mean, you can try it yourself. Rate 100 movies, come back and see how accurately you would re-rate them again. So feature engineering is quite important, I think, because it makes you try to capture the gist of what you're trying to analyze in a more easy, computable manner. Because also it's much easier to compute.
I'm wondering, does your community use Mechanical Turks or people as a way of helping you understand? Because in some ways, a Mechanical Turk platform.
Graduate students.
Okay. So I'm wondering about, because to some extent, designs try to use it's working with people more than ever to help itself understand problems, challenges, opportunities.
Yeah, there's some Mechanical Turks usage. Another one which is often, I think, one of those things called gamification. Sometimes people actually give you data away for free. So somehow, if you can spin it around as a service and make them people like Pinterest, you always put tags of your images. So they got really nice database which already pre-tagged.
Yes.
So this would be, I think, a better approach because you get data for free, and also you provide some value back to community.
Yeah, great. Yeah, Foursquare did very well to build their database through gaming, didn't they? Yeah.
And then, if you think that if this place missing, you would put a restaurant in, so you're basically doing their job. But I think there has been some backlash because a lot of companies will just get your data and sell it and then discontinue the service. So in the beginning, everybody was very altruistic, but I think now it's a more complicated question. Sorry.
And there was a month ago, an artist was actually visiting Amsterdam. He did a walk with Neural Talk, which is software image recognition that is used for closed captioning automatically. And he basically blew people's minds because it was basically transcribing what it saw. And actually, I think about 90% it was completely wrong, but sometimes it was right. And people would go like, whoa!
You can see me.
Even I would go like, how does it know that? Whereas it is actually quite wrong. But so the thing is, if you give people a lot of wrong data, but sometimes right, they immediately go, oh, this is amazing.
Yeah.
So how do you sort of, as a designer, you can also play with the notion that you're already. So I'm very impressed by Google Photos, and actually it gives me my own photos. Very many wrong photos, but sometimes they're good, and then I'm very sort of, how do you deal with the way we react to the intelligence we see in a system?
Yeah, sometimes also if it's too right, you're kind of like, whoa.
Yeah, yeah.
I didn't know this is my
Yeah.
niece, it should be some random person here. So,
Yeah, so how do you deal with the sort of uncanny valley, and so how does machine learning play with the expectations of its users?
you don't do much user research in machine learning. No, actually, it's true. Actually, I think this is one of the things I found out. So I've been mostly a very traditionally trained machine learning person, and I think collaborating with Lisa and Chris has been quite eye-opening, because usually for our papers, all we care is about accuracy. I have this fancy algorithm, it can get 85% accuracy. Next year, if I could get 87%, I can get in the top menu. We don't do user studies. So I think this is something that should be...
The way you present it can make it more forgiving. So I think basically, so image recognition is very easy. We as people can go through 1,000 images in one eye and go, oh, this is amazing, it's quite right. Whereas it's actually quite wrong.
Yeah. So I think also it's interesting because sometimes people think that some tasks are really easy, but actually they're really hard, or sometimes opposite. For example, actually predicting movies, people think, oh, it's really hard to predict whether I will like this movie or not. But the thing is, actually, once I have millions of users, I can actually say, okay, if I liked Star Wars 1, and then I liked some Cuckoo's Nest, I can find another people that had the same exact ratings, and then I don't even need to do anything fancy. I just have to see what other movies they watched and what did they like them or not. So it's super simple, but actually it's really, really accurate. But people try to always reason, oh, he likes this movie because it has this plot twist, But actually, the algorithm that now are most highly performing now, they just try to find somebody else that's like you, and we always say we are unique, but actually we're not. So yeah, sorry.
Can you explain how it doesn't work with hotel bookings? Because if you book a hotel through booking.com, then 1 week later you get a suggestion to book another room at the same hotel.
Oh yeah.
They're also using machine learning.
So I think I have this problem often, because I spend so many hours trying to decide which hotels I go to. I usually actually just use Hotwire, because I say, okay, I want 4 stars, this price, and pick one. But I think one of the problems with, let's say, Booking.com, they just average everything out. So the average user would like this hotel. So they don't really actually look at your user history too much, I assume. Also, the thing that also their motivation sometimes is profit, right? They might think that there's really a small B&B that costs 30 euros that I would really like, but they'd rather sell me something that costs 70 euros, and then they get 20 euro cut. So I think sometimes they don't only try to cater to you. Yeah.
One question about a topic which you haven't mentioned, which is data quality. Because if we move sort of in the IoT realm and we talk about sensor data, we have to deal with the fact that a lot of the data is noisy or might be plain wrong because the sensor is not working properly. Now, this is separate from machine learning, but what's sort of the interaction between machine learning and management of data and quality improvement of data? Data noise is always a concern.
So one of the tricks we use in machine learning, we basically say, well, if we have more samples, the noise will average out. So there is some natural variation, but the thing is, once you have many samples, you have the kind of true mean. Then you don't really care about the noise as much. But there are also some sub-areas which concern that it's actually not noise, it's actually maybe true reading. So there is one that is quite interesting. I have some friends working kind of on industrial, like engine analysis. So it's called change point detection. So for example, you have an engine that has certain operational characteristics, it kind of varies, of course, and suddenly you have some fluke. And then is this fluke noise, or is that actually something in the engine changed? And actually, it will keep working, but if you have more and more kind of these flukes creeping in, this actually could mean there's is the sensor was bad, or actually the worst case, actually some hardware is becoming bad. So you should really look at it. So but it's also hard because one is actually trying to distinguish when things change, when they don't. And I think it really depends on your final purpose, because I think in certain areas noise is okay, we don't care if you're wrong 20% of times, but if you are doing a rating system, you want to be 99.9% right. So
I'm thinking slightly different topic, which isn't actually sort of going into machine learning perhaps, but so the way we use data is with creating a certain kind of user experience. And so yes, we do need to understand general patterns of human behavior, and we can use some of the algorithms which you discussed, but on the other hand, we need to create a user experience which is based around a very concrete small set of data, what is happening right now. And so there it is critical to actually, that the data which you display or what you use to demonstrate the user experience is accurate. Can you use machine learning to improve the accuracy of the data?
Yeah, so one of the things that is kind of addresses this question in some ways is this. It's actually not machine learning, but it's usually recommendation systems, but they do personalization. So basically, what we typically do is we make one model that tries to predict everything, but in recommender systems, they will actually try just to model me. So they will create a model just for me. Then, of course, it will be much more accurate, or try to take into account my specific behavior. Because if you just make one model, you just basically average everything out. And it works for most people, but for some people it's just really bad, because if you're not an average person, it will look like you. So I think by kind of doing more sub-modeling could work. So I think maybe over the last 5 or 10 years there's more move towards kind of this more niche cases, or not niche, personalized cases, because as user experience, I want to have my own user experience being very good all the time.
I just wonder what you see in terms of the next 10 years or 5 years of your research, because at the moment in Edinburgh, the machine learning group are just getting hit from commerce. Mm-hmm. We've got big data sets, Tesco big data set, we've got big data sets which are largely based in commerce, mm-hmm. And help us identify new market opportunities. And I wonder if you're seeing a movement away, or that's just where the market, so what's going on in machine learning next that might shift it, or where do you need to look for to shift it?
So I've done plenty of consulting for trading companies, stock trading, because that's where I think there's some statistics that 30% of machine learning PhDs end up doing stock trading. It might be decreased now, but it's quite high because they have a lot of money, and if you can improve something by 1%, that's cash. They can easily pay you a very high salary. Luckily or unluckily, I think there is more now starting to be a little bit of move towards consumer-oriented products. For example, if you make some small startup that will try to predict my patterns, I can make decent amount of money by just providing good experience. So I don't need to have some other intermediary to provide value. I can try to provide value directly. Although we are pretty bad at making user interfaces, so usually the apps with good accuracy look ugly. So
So you would advise design studios to have a machine learning expert,
Sorry?
to have a machine learning expert on board in the next 5-10 years?
I think it would not hurt. No, it's a biased opinion, of course, but I think also tools are getting much better. Like, I think it maybe even like 10 years ago, you probably needed somebody with PhD. I think now you can get away with masters, or I'm oversimplifying, but as long as somebody knows how to use tools, they might actually be able to give you a decent model. And tools are just keep getting better and better. So in a way, we are trying to put ourselves out of job because usually machine learning people are pretty good at coding, so we will code things up. And so there's a lot of algorithms which are free that will actually improve your own model. So
So do you think would it be possible to train master students to some basic machine learning?
Yeah, so-
Because they say we can move from a PhD to a master student
Mhm.
because now we have the tools. So all of a sudden I thought, well, could you actually have a course, for example, for our master students of 3 months or where you can?
yeah, I'm sure that. So actually, one of the actually good products.
Yeah, but I mean,
One of the good products is and Microsoft have launched called Azure ML. So it's actually machine learning by Amazon, and it's actually mostly like blocks. They already have some pre-made blocks for some certain kinds of machine learning. You just basically connect them. So it's really the learning. What do you call it? The learning slope is not as high anymore. As long as you can have some idea about what the block does and how you connect it, you can actually get pretty decent results. And I think it's just gonna keep getting better.
Great.
Maybe if I can add to that. So, for example, on website like Coursera, which do online MOOCs, the chief data scientist of the Google Brain project is now working at Baidu, making their driverless cars. He teaches at Stanford, and his entire course on machine learning is available for free for anyone.
could you name me that? Since I'm part of the graduate school, I'd like to.
Sure. And that's just one of the many courses
Yeah.
of machine learning. Plus, if you really break it up into the different steps of machine learning, the algorithm or implementation for big data set comes quite at the end. First, the conceptualization, finding which features, visualizing for sample data set. Does this make sense? And those kind of things, even a designer could do with software and calculator. That's it. Designers are. I'm saying we don't have to be coders.
Yeah, I know what you mean.
Sorry, I'm told to get lost.
Thank you.
Yeah,